Hello everyone. So today we are here to attend a DevOps webinar. Today I'll be talking about culture. So let's get started. Can I get a quick feedback from the people that you can see my screen and also hear my voice so that we can go on with the presentation? All right. So let's begin up with the session. So my name is Ashish Nanadkar. Um, I have 7.5 years of IT experience, and these days, for last 3 years almost, I have been practicing DevOps. I'm responsible for setting up DevOps pipeline for the biggest projects of some of the biggest IT giants like Seagate, Sears. Then I've worked with Nimble Storage. Okay, so I've got pretty much background of different kind of tools, the culture setup, how to transition on DevOps. These are generally the problems that people like to address while they are jumping from non-DevOps background to the DevOps background. Okay, so today we will be covering up 5 best practices that you should be doing that in the DevOps. Okay, so that's what we're going to cover today. So let's see what's the agenda for today. Today we'll be covering up our topic, talking on these few points like what is DevOps, why the DevOps culture is important. Okay, so there could be cultural, structural, and tooling kind of 3 different areas where you have to work to set up DevOps. Tooling is not the only part. Of course, during the classes or during any other teaching courses that you people might have attended or are willing to attend, these people generally target only the tooling part. Okay, but today we will be talking more on the cultural aspects of it. The what is the cultural part, how to structure different teams, what should be the correct hierarchy of your DevOps team, and how to go on with the tooling section. There are different stages of the tooling, of course, that should have to be covered. We would also be touching on how different organizations have implemented DevOps so far, a few examples, and the outcomes of it. Okay, so you should at least know what is the target that has to be achieved. What are we doing all this for, right? Different DevOps tools that are famous these days in the market, and the 5 best practices of DevOps culture, of course, that we are all are going to attend this session for. So, from a eyes perspective, what is DevOps? Actually, it's infrastructure automation. That's what it is. So you could be automating anything, starting up from maybe style checks or syntax and semantics checks to building the code and then deploying it. All of these is DevOps. So it starts with the developer, okay, and eventually gets uh, through a series of automated tools and systems coordinating with one another to the endpoint in the ops area. So generally what happens whenever we have a code that is supposed to be deployed into the production and it's working on the developer side and even the testers is to be tested. Once that's done, the code is moved to the production through a series of whatever steps you might be following. Every organization has its own mechanism and steps to be followed. Okay, so no one does DevOps exactly the same way. Everyone has their own ideas, their own steps to be followed. Okay, so right. So, but generally, when we look towards all these implementations of DevOps from a bird's eye perspective, we have this general problem that it's not my code, it's your machine's configuration which is wrong. And on the deployment side, people say that it's not my problem. I have followed the exact same steps that were supposed to be followed, and it's your problem. It's not working. There might be some bugs in that. As simple as that. So and also, there are different areas like CI, CD, and CD. Like continuous integration, continuous deployment, continuous delivery are the 3 biggest sections that people have identified in DevOps. And only in those areas, tools are available these days. Okay, so let me do a quick sound check. A few of the people are complaining about the sound. Hello, everyone. Can I get a quick confirmation that you guys can also hear me and see my screen? You can type in your chat window so that I can see them. All right, wonderful. Thank you so much. Well, thanks for your feedback. So let's start with the presentation. There was a small glitch there, so you guys were not able to hear me. Well, that's fixed. My name is Ashish Nanotkar, and I am in this IT industry for last 7.5 years. Have been working in DevOps field for almost 3 years now. I've worked with very big giants like Seagate Technology, Sears, Nimble Storage. Then there's Zento Systems, Clogeny, Entrada, and helped these guys to set up DevOps on their biggest projects. So not just tooling part, I've helped them in setting up their culture, what should be the structure of the team, okay, and sorry, and also the tooling. So definitely the tools are important, but not as much important as the culture and structure. People generally like to focus only on the tooling part. Well, tools are necessary. They provide automation. Automation can also be done by writing a small script, as simple as doing a simple rsync to push your code to another machine. That's also DevOps. Okay. So depending on the scale that you have or the code and the projects that you're working on, it differs from company to company, from organization to organization. So what we are going to look into today are the 5 best practices in DevOps culture while we are setting up DevOps or doing a DevOps transition from non-DevOps to a company or a project which is depending on DevOps for its feature releases. Okay, what should be the important points into that transition? We'll be covering that up. So today's agenda is we'll be talking a bit about what's DevOps, why is DevOps culture required in the first place? Okay, why not just tooling? Why not just automation? How different organizations have implemented DevOps, a few examples of that. We would be looking into a few of the famous tools that are being used today, and also what are the 5 best practices of DevOps culture that the presentation is going to be covering. Along with that, I would also be sharing my few experiences that how we have done it, what are the pitfalls of implementing DevOps, what not to do, and of course, I would be open for questions. Feel free to ask any of the questions, even in the between of sessions. You could type in the questions in the chat or raise your hands. I would unmute you and we can have a good discussion over it. Okay, I would also keep at least 10 to 15 minutes of time at the end of the session so that you guys can ask any questions that comes to your mind, not from the culture, maybe even from the structure or the tooling part, or you have a case study or a scenario that you want my help on. I'm free for any kind of discussion that you might want to draw me in. So what's DevOps in the first place? So from a bird's eye perspective, like from the real height, so what does DevOps look like? It's all about the blame game. That's human psychology. That it's working on my side, it's not working on your side. I'm not the person who's supposed to be blamed, it's you. So, well, both of them are right. It's not working on the production side, it's working on the developer end. So both of them are correct. But how do we make this transition? Definitely, we are not going to deliver the developer machine or developer environment to the clients. And production systems are the systems which are more critical. These they are revenue generating systems. Revenue is generated on that side, right? Because clients would be accessing only on the production side. So this blame game has to be moved. So the flow of the code or the project or the artifacts, whatever you might be creating in maybe C, Java, .NET, PHP, Python, any language you choose, ideology behind that remains the same. The steps that have to be followed more or less are same. So I'm talking of steps. I'm not talking of exact filters or procedure that you would be following for doing that. Because Java code might require some another build tools. C might be having some other dependency factors. .NET is completely different. Then you have Python and then something like PHP and whatnot. The things might be different, but the steps or the stages like continuous integration, continuous deployment, continuous delivery happens to be the same all across the companies. Okay, so from that point of view, DevOps is about solving the problems of environmental glitch between two people, and more or less, it's about automating so that we save a lot of time. So in earlier days, if you remember, there was a waterfall model that was being used for software development. Software is being developed in 3 months, 4 months, depending on their length and size of the project. Might extend even up to 2 years, 3 years of duration. And after that, they were production ready, then tested exclusively in production, pre-production mode, and then deployed to production. Well, imagine after 3 years of time, you figure out that there was an architectural deficiency in the design phase. Okay, so that's a big problem. So what people used to do is in those days, they were relying on the design team to be perfect. Okay, if any problem is there, it would be on the part of architectural team or the software architect to fix it, to figure out what the problem might be. Okay, and then take some steps so that it doesn't reoccur in the future. But today people don't like to wait for that long. Everyone, if you see that these days we are not developing standalone products, we are developing products that are used by people as services. So apps, websites, shopping carts, e-commerce sites, payment websites, and any of the things that you see on web these days, it's not a standalone. It has some kind of integration with some another sites and so on. It's more complex. It's not just a web layer. There's a lot of coding and logic and business sense that goes behind the scenes to bring up a small, simple web page or app to for the clients. Okay. So while this is happening, you need to coordinate between all the different layers, and the development has to be very fast. We cannot wait for 2 years, 3 years for the app to be complete. If you're ready with one single feature, release it to the public so that you get quick feedback. So you develop incrementally. You use not SDLC, but you use something like RAD or prototype model or maybe spiral model or even hybrid of all these things together. Okay, so the things might be different from different apps, but essentially the thing is we need to develop incrementally. For developing incrementally, you need to test the whole piece with a new small addition that you have made. Let's say you have a software that is having 100 features. Now you are going to add 101st feature. Once you do that, you will have to test the whole software so that the 101st feature that you have added doesn't mess up with anything there. And that adds to a very big overload on the testing side. Every time if you test, you'll have to test the whole software. Now that's a big deal. You can test one single piece of feature, well, that works, but you cannot be sure that it should work in production with along with all the other features, right? That's where you need automation. Very first requirement of automation was for the same reason, that we need to reduce the time we spend on testing part. But most often, even if we spend time, we cannot guarantee that it is free from human errors. So let's say I write a script. I know there are going to be 10 test cases that my software has to follow for smooth functioning on the production end. I wrote all those things in a script, and every time I add something new to the software, I just execute that script and it checks whether the software is running properly or not. Okay, as simple as that. And that's automation. But writing a script and automating it, it's on the tooling part. We have got tools for that. Capistrano helps in deployment. Jenkins is a continuous integration server. Then there is configuration management systems like Puppet and Chef, hardware management systems like Cobbler, Foreman on the infrastructure side. Okay, so there are n number of tools specifically dedicated to different areas. Okay, but that's the tooling and automation part. But very importantly, we need to have a work culture in place so that everyone knows what is the end result, how we need to achieve it, how we need to work with one another in order to get there. Let's say you have a complete pipeline setup, but no one is willing to use it. People resist change. They don't like to leave their own comfort zone and do it. Okay, that's the factor that you need to change in a team. And that's what takes time. Setting up the DevOps stuff in an organization never takes time. Okay, it's very much simple. It would take maybe 2 hours, 3 hours. Okay, that might generally take, and for setting up the things, and later on it takes more time for the team to accept it and transition from non-DevOps architecture to the DevOps architecture. So we'll see how we transition there. So generally, what I'm talking of is this: that the developer would create something, it works on his box, he moves it forward. That's the commonest problem, okay, or the biggest problem. So in today's business environment, where we are increasingly fast moving, we are competitive, we are technology driven world, okay, so we would like to be ahead of other people and implement ideas as soon as possible. So let's say I have an idea of a new feature that might give me a competitive edge over my the other rival who is also serving the same kind of services. Or maybe something changed in the pricing model, or a small change with a feature, or I want to add a referral program that would send out payments to other people who are using my apps and so on. So that's just an idea, right? But as soon as I have an idea, I need to implement that in a matter of 7 days, maybe at max, because I don't want other people to get ahead of me. But no one have thought of that feature when the app was actually created, right? So they need to make space for this new requirement, adjust it, change the app, deploy it without any downtime, and that's important. So it could be 5 nines that you're guaranteeing in your SLAs, or 7 nines that you are guaranteeing to the client in your SLAs, that our app will not be down. If you're talking of 5 nines, it's less than 5 minutes a year of downtime that we are talking of. And all of you know that if you want to work on a database and there are some big schema changes, you'll have to take the database down eventually. Okay, so that's the big problem, and we don't want to be down for our clients at any point in time. So we also need speed, agility, faster time to market, becoming increasingly important. I don't want to spend more than 7 days on that feature, or if it is very small, I would take a day. If it's a bug fix, let's say my login system is not working, how long do you expect the client would be waiting on your website for checking on the login bug? Not much, right? So that's what the problem is. You cannot take more than a minute or two to fix that bug. And at last, these application softwares are a new battleground for people. You need to be ahead. You need to fight. You need to be never down. You need to keep your system serving. There are hackers. There are background bugs that are going in. So no software is bug free, and we need to accept that fact. Okay, so with all these big companies that I've worked with, I know that there are hundreds and thousands of bugs that are open, that are still there in the software, but no one on the client side can ever figure out that something is wrong with with the software. They don't have any problem accessing the app. The services are still on. They can still use it, and they're happy with it. Okay, so how do we maintain that kind of scenario, that we do have bugs, but we are aware of it? We need to still keep the app running, okay, because we need to serve the client. That's what DevOps is about. And we would be talking more on how people have achieved it and what can we do to achieve it from a technical perspective also. Okay, I'll be answering some questions regarding to it if you have some at the end of this session. So let's take a look at what the job trends are. From It started all from 2011 onwards, and this year there has been an exponential growth in requirement of DevOps people. Okay, now this DevOps people belong to different areas. DevOps is not a unified or one single term that this person is going to be called as DevOps person, not the another one. So there are different zones in DevOps also. You could be a build engineer, you could be a release engineer, you could be a build pipeline engineer, or a continuous integration engineer. Okay, so things are different. You could be an architect. So it depends. And also from the tooling perspective, people these days have openings for jobs like puppet engineer, chef engineer. Well, that's no kind of a title to be given to a DevOps person, but it refers to the skill set that these people are referring to. And this is taking the companies to a very different area. They are derailing from the fact that what is DevOps actually about. It's about not just automation, but setting up the culture and structure also. So what people are concentrating these days is only on tooling, and they are doing the DevOps wrong side. They are not doing it right. Okay, so that's why we have come up with this kind of webinar, so that you can do the right things at right time. So what Amazon has achieved with its DevOps team? Well, Apple was the first company which completely changed their ops team or operations guys or IT guys by DevOps persons. Okay, so they took up they adapted to DevOps at very first, and then came in the bigger giants. Now these companies like Google, Facebook, Twitter, they were already on the DevOps side, but they never released their findings and procedures in market. Twitter was the first one to do that in 2009, and since then the coin was found. The term was coined that the DevOps, this part is going to be called DevOps, and we need to do this. There are going to be some processes that have to be followed, and so on. Later on, it moved ahead, and these days everyone is trying to get hold of it. Well, because company sees value in that. Uh, Value in form of cost, value in form of time reduction, value in form of reduction in human resources that are required to deliver a software. That's also important. So Amazon deploys one single deployment every 11.6 seconds. That means in some part of Amazon architecture, now they have a very big application, a huge fleet of people developing and committing things onto the production every now and then. Okay, we are not talking of the cloud, we are talking of their application part. Okay, like Kindle and Amazon.com and their service architecture, what they have. The deployment is there every 11.6 seconds, and at max they have deployed at a rate of 1,000 in an hour. That means 1,000 times the code has been pushed successfully and running without any interruption in Amazon systems. Facebook, they have the code size of 1.5 GB, and since it's a 1.5 GB code, you need to make sure that every feature of it is working in properly in the binary, because you cannot make the changes to the binary on the fly. It has to be built remotely, then pushed to the production sites, and then it works. Okay, so it takes time, and but it doesn't prevent them from releasing the stuff out. They release multiple times a day. Okay, at Etsy, now these people serve almost 1.5 billion page views per month, and that's too much. Okay, so since that too much, how do they keep up the servers? And on the busy day, like maybe a Christmas Eve, where or pre-Christmas areas, pre-Christmas time, like a week before, where there would be almost 4x 5x increase in the traffic, how do they manage that? Do they order new servers, or do they configure new machines, or do they go for the cloud? Even if they are going for the cloud, how do they prepare themselves for such kind of deployments? That's a big thing to ponder about, and that's where DevOps would be helping these people. So the first part here, out of the 5 points about DevOps culture that we need to take care of, the first one is the training. Team has to be trained not only on the tools but also on the cultural perspective. So when I'm saying culture too much, um, we don't have classes for teaching culture. So what we do is we teach them the processes that they need to follow, and we also show them the value that the processes would be coming out. Um, Once you start following the processes should be followed as part of the culture, not as the part of something that you need to follow because you are doing a job there. Okay, once you start uh, appreciating the values that the process are giving out, you follow it as a culture, not only in one single organization, but you will be taking it to another one as well. Okay, so it takes time to learn new tools, and it's acceptable, right? One person can get hold of it, but maybe another person is still trying to learn it, getting around with it. Okay, so it takes time. So DevOps transition is never fast. You generally take time. You eat one thing at a time. So it's not the case that the complete build pipeline has to be built in isolation, and then you tell the developers and the production guys that this is now ready and you have to use it. That's not the way DevOps transition works. We need to appreciate that learning together is fun, and it has to be done the same way. You cannot sit in silos and do it. Since the DevOps structure is horizontal, we don't have vertical hierarchies, vertically bigger hierarchies in DevOps. At least it will be one or two at max, nothing more than that. So that's what we are targeting. And communication is always horizontal. So you could jump from DevOps, the developer can jump from his cabin to maybe DevOps area. The DevOps persons can go to the production sites and then figure out what's going on. Okay, even from the monitoring and logging perspective, the developer is aware of everything that happens to his written code. So the ownership, the code ownership is increasing. Okay, so once you get a feel of ownership that this code belongs to me and I am responsible for it in the production, developers start taking responsibility for it. Otherwise, it's not the responsibility. Okay. Okay. So also in DevOps team, you have people who belong to very diverse nature. So there might be a few developers, there might be a few testers, a DBA, a guy who is belonging to ops side, a person who is aware of all the tools and can do some integration, some scripting guys, and all of these people share their knowledge with one another so that the team grows as one single unified team, and everyone is aware of everyone else's areas. So if something goes wrong, we are aware um, that who can solve this particular problem. You don't wait for someone else to recognize it, figure it out. Well, until then, it's too late. Okay, so let's see. That's what was on the first point. There are a few also skills that are required for the people who are working with the DevOps teams. So very first is Linux, Unix. You should be aware of the Unix boxes and shell scripting and so on. A few commands like that. The reason for that is 80% of the market is the Linux market on the production side. I'm not talking on the user base areas. I'm talking of the servers. Of course, there's a market for Windows also. That would be too much specific. So at least as a general DevOps person, you should be knowing something about the operating system you're on which you're going to deploy. Linux, Unix, or Windows. Commands and administration part should be covered. A little bit about shell scripting. Now, it could be Bash. It could also be the batch command line on Windows. Okay. On the coding side, you need to know a language that works closely with the system so that you can automate the things at the system level. On the configuration management perspective, a few tools like Puppet and Chef can help you out. Bare metal configuration is extreme DevOps that very few people tend to reach. Okay, in that area, you should be aware of the stuff like Cobbler, Foreman, some private cloud systems like OpenStack are also included in that list. Okay, so if we chunk down the tools in different layers that the DevOps consists of. See, build pipeline is the horizontal pipeline that starts with, or are the stages that starts with the developer end and it eventually goes till the deployment. But this complete pipeline is then chunked down into different areas. Okay, these different areas start with continuous integration, then they go to configuration management, infrastructure automation, continuous deployment, and then monitoring in that order. So on continuous integration side, we have the servers like Jenkins and Hudson, which was predecessor of Jenkins. A few version control systems are there. Building tools are also there that are being used in continuous integration part. Configuration management, Puppet and Chef are the biggest players in the area. We also have Ansible, SaltStack that help us out. Infrastructure automation is left for Foreman and Cobbler. Puppet can also help you with that if it is configured right for that purpose. In the deployment, one of the nicest tool is Capistran that can take care of all different kinds of deployment schedules that you might be having. It could be rolling deployments, blue-green deployments, or red-green deployments, any different kind of scenarios that you might be having with your application. It plays nice with Java and also with the binary files that you want to deploy or a plain code in a variety of operating systems, whatever your targeted nodes might be using. And at last, you need to keep telemetry always up. So the things that you cannot measure, you cannot optimize. That's the rule. Okay. So if you don't know what were the statistics of your application yesterday before deployment, so you cannot measure that what the impact was during the today's deployment session. That after deployment, whether the application is working fine or not, whether it has been slowed down because we have added a few new features, or whether the performance has been enhanced because of some optimizing code that we have added. So for monitoring, you need the applications like Nagio, Sensio. There are some analytics tools like Logstash that are available in market that are really good at doing things that they do. On the revision control systems, there are two different kinds of revision control systems generally, centralized and distributed ones. So on the centralized, we have Subversion. Distributed, people like to go with Git. Then there is Mercurial that's coming up. The public version of Git or public interface of Git that people like to use is GitHub. Of course, there are other providers too that provide this kind of system, but their plans might be different. Software configuration management. But these tools are not being used extensively these days because Puppet and Chef has completely replaced them. Like ClearCase or Accurate were the leaders in that area. Okay, people still use them if they are using it for a long time back. And of course, virtualization. So these days, people are not depending on one server per one hardware kind of scenario. Rather than that, they jump to virtualized containers. Now it could be Docker or Vagrant that these people are using, or also some systems like Hyper-V vCenter that allows you to create multiple instances of operating systems on which you can deploy and create machines. So one single hardware can execute 4, 10, 20 depending on its capacity. Okay, so that also helps in cost reduction with a very big amount of factor. So here at uh, like the general tools that are being used in DevOps that will help you to achieve the things in a very general manner. So let's stick to the open source tools that are available in the market so that no one have to purchase a license for that. So when we're talking of open source tools that can solve majority of the problems of DevOps, let's start with the first one, Puppet Labs, that helps us in configuration management, also in deployments these days. We have got Nagios for monitoring, Nginx as the fastest web server available, and also reverse proxy systems for dynamic serving dynamic web pages from Apache or any other web server that you want to use. Git is getting famous these days for providing the capacities of distributed system that allows greater collaboration between the teams, and Jenkins as the automated build tool. So if you master all these tools together, you can get an idea of all the different levels and stages that the DevOps um, person have to configure and set up in different organizations. Well, practice number 2. First one was the training part. I've also covered what are the different tools and what are the skills required for a DevOps person. The second practice is to share and speak out. So if you know something about your project, share it with your team. Share it with other teams. Okay. So externally doesn't mean outside your company. It means with other teams so that you get an insight of how different teams are working on the projects, how they are achieving the things. Okay. Agility is the stuff that is agility is the key to implementing all this stuff together. Always have multitude of skills. Well, it's good to be a master of one, but it's always better to be a jack of all trades. I'm talking specifically about a person who are working in the DevOps area. So they should be aware of what is happening with the application, how it is structured, why it has been configured this way, how to even create a feature. If you're not even doing it, you should be aware of how to debug it. Okay, reverse engineering is the key, where when you need to refactor all these things together from your application point of view. Then you need to know about um, core automation, creating scripts, a few tools that can help you automate this stuff. Definitely, we are not going to reinvent the wheel. If someone has done the things already and it's free, it's able to be used, or your company is ready to pay for it, it's okay. Otherwise, you'll have to do it all by your bare hands. And you should also be aware of the administration on the system side. Okay, that's what is expected from a person who is willing to take up the role as a DevOps engineer, not specific DevOps engineer, but a general one who can do everything single-handedly. Okay, definitely you wouldn't be perfect for the first time, but start with very simple things. It could be checking for syntax error in the beginning, not building the complete code. No one expects it to do that on the very first day, but start with very small things, build one thing at a time around it. Okay, and the problems that you're facing are not the first occurrence of those problems. Okay, so people have already faced it because they are operating at a very high skill already. Okay, and you're not the person to get along with it. So search the internet, look out for help, ask on the different forums if they have faced it. Okay, and if they have, they would be willing to help you. If you don't find a solution, find a solution yourself. That's what it is. And if you see value in your product or in your solution, contribute to the community or create a product around it. So whatever your market strategy would be, you could go ahead and do it. The next practice would be to change the process. Well, change is difficult, but change is beautiful. um, People generally don't see the values that the DevOps process would be bringing to them, but definitely you need to make sure that they understand it. Once they understand it, they are willing to change a bit, one step at a time. Okay, so change is something that is required for non-DevOps people to be jumping to the DevOps architecture. It's completely different. We bring agility from the software development stream to the hardware, and that's pretty much difficult. People on the hardware side are a bit resistant about taking in the changes every now and then. Of course, it's more critical part, right? You can mess up with the software on a developer machine, but you cannot do that or the same things on the production area. That's what is important. Improve and automate whatever is possible and wherever it's possible, as small as it gets. The fact is that let's say there's a developer who is wasting 10 minutes to parsing the code from one box to another box, logging into that, doing a copy, then moving the code to some different folders, changing configuration, so on. At least 10 minutes are being spent every time he tries to test the code. Maybe he tests 5 times a day. So if that's the amount of time that he spends, it's almost 50 minutes. And if there are even 10 developers working on the same project, doing testing 5 times a day, it's going to be 50 multiplied by 10 is 500 minutes that people spend, almost 8 hours 20 minutes. You can save that time every day for those 10 developers. Okay, that's how we bring the value. And since it's agile process, it's self monitoring and self organized way of developing the software. So you don't need managers to be sitting on top of the teams to figure out what's happening and make them work. The next practice is to get hold of your culture and implement it in right way so that people collaborate and think of one another as a family. We don't want to initiate quarrels between them. Horizontal communication should be there. That means the teams should be sitting, maybe even if they are sitting apart, the communication should be there. They should be aware of the people in one another team and they can reach out to them as easily as possible. Okay, getting via mails, waiting for the calls, dialing numbers doesn't help. They should be present on one single floor. If it is a geographically distributed team, they should be using the days and nights to shadow one another instead of waiting for a round time of 24 hours or maybe 36 hours. Trust should be there. Okay, everyone is specialized in their particular area, but everyone knows what other person is doing, right? So if that's the matter, when you're aware of other person's roles and responsibilities, you also monitor that person, that if he's working on that particular part, I need not to be worrying about it. I just need the results that this person is working on. As simple as that. Okay, so there should be trust, and ensure focus on business service and not technology. Again, I say it's not about tools. It's about automation. It's about getting the stakeholders aware that what is being changed because you are implementing DevOps in your organization. What is the value that it is bringing us to us? What is the cost impact because of the DevOps? And what is the time impact of it? It doesn't mean that once you are setting the projects using the DevOps pipeline, it is not going to be the case that if you are developing the feature in a month, you are going to develop it in a day. Well, it takes time, but we definitely are going to reduce the time. We are definitely are going to reduce the downtime that the application takes on your production systems. We are going to set up the culture right so that the people are more playful. They get their time. They manage their work-life balance well. Okay, and they don't spend more than 8 hours doing their work in the office. That's also matters. Okay, so this is from a perspective of a good DevOps engineer. He should be able to understand even the psychological part, not exactly that, but you should be aware that this person is doing his work repetitively for majority of the part. So how can you make his life easy? It's about making lives easy for the people. So if you have a zeal for automation, if you believe in making people's lives easier, you can be a good DevOps engineer. Definitely, it's not about tools. You can get to tools later on, depending on uh, whether or not you understand the concepts of it first. And conceptually, when it's divided into different areas, pick up a tool that works in that particular area and get your requirements in line. Okay, so that it works in accordance with your project requirements. And at the last one, build a diverse team. So I've been talking a lot about diverse teams. You need people who are working with uh, who come from diverse backgrounds. They may be specialists in their own areas, but they should also know what other people are doing. Okay, so build a project team having all the different skills. Now these different skills can be related to different areas. So there could be a good developer who is targeting on not feature development but on code optimization. So code optimization also comes under DevOps, but very few people know it. They understand DevOps to be after development kind of scenario. Well, it's not that. It starts from the developer machine right itself. Okay, even before the developer starts coding, DevOps starts. So the first part would be the development, then continuous integration, taking up the code, checking it, scanning it, building it, deploying it, testing, and after testing, doing load test, stress test, smoke tests, doing all these things together, getting the artifact ready, deploying the artifact to one single production box. From there, your configuration systems would be taking it and then deploying it on multiple systems or multiple nodes. But this deployment has to be the beta deployment, not the alpha one. So uh, the alpha deployments happen internally, the beta deployments happen on the production, but on a very specific area that only these few systems would be deployed with the new code, people will be starting using it. Then test that part. If it's working fine, then roll out the changes to your infrastructure. And at the same time, you need a system that would be sending the logs, the stats back to the controlling systems so that you can monitor anything and everything that is happening on your environment. So attacks are not a new thing. There could be a DDoS attack. Okay, there could be a worm attack that is happening, or people are trying to hack into your security systems and whatnot. Okay, so people like to do n number of things once you get famous, and you need to have a way to track all those things using your DevOps infrastructure. Okay, so there's also security that is coming in. There are firewalls. There should be different monitoring systems, near real-time analytics, static analytic tools. Server hardening is also part of DevOps tooling section. That's why you need to know something about system administration when it comes to DevOps. Either it could be from the Windows perspective or from the Linux perspective. Okay, so the five practices that we have talked of is what we need to build up a right culture. And so far I haven't talked of any of the specific tools regarding to tooling, but I can give you an example of it. Let's say I want to have um, a system set up with help of DevOps pipeline, and the code is written in Java. So this application is supposed to be deployed on maybe 1,000 different nodes on the production area. So what are the tools that are required for me? So very first, I'll start from the DevOps, the developer perspective. From the developer machine, I need to have a pre-commit hook that is there. I need to send that code to some code review tool. I would be maybe using Review Board for that purpose, or Gerrit, or something like Fabricator. It depends. I would be using a distributed or a centralized revision control system like Git or Subversion. That's where the code would be moving. Once the code is at the revision end, at the centralized code repository, from there we'll be picking it up at Jenkins. Now this is a post commit kind of system that Jenkins handles. Now Jenkins is the continuous integration server that can implement variety of checks like syntax checks, semantics checks would be there. You can also do this on the developer machine itself. Then the code would be built in different areas. There are different products, different branches. You could be trying and testing them on different systems or on different environments. Maybe the code should be working on JBoss 8 or JBoss 6, 5, whatever versions you are using. Maybe all of three at once. So Jenkins would be responsible for building it in different sections, then deploying it on its slaves and checking whether it's working or not. If it's working, create the artifact and push it to some third-party repository, maybe like Nexus or Artifactory. Okay, so till then we have used a lot many tools. I have used, okay, I'm talking of just one tool per section. So it could be a pre-commit hook, Subversion, then Jenkins, then it goes to a Linux machine. From there it goes to Artifactory and JBoss. Okay, so we are not done yet. From the Artifactory, the builds are then triggered for the production systems on the final build system. So once that artifact is ready, you deploy it directly to any of the configuration management systems. Maybe I use Puppet for that. And from that Puppet master, all the nodes are triggered for deployment. So the artifact then moves from Puppet to the nodes where the agents are running. And eventually, it executes on the production side. So that's how it works. But it's not as simple as you think it is. But everything has to be automated. Once we commit anything on the developer side, the code should freely move easily from the developer machine to the production systems without any manual intervention. That's what the end goal is. Okay, so this from the tools perspective, that tools should be aligned and integrated in such a manner that the code would move without any manual intervention from the developer machine to the production system. That's what the end goal should be. All right, so that's about the cultural part that I wanted to cover in this today's webinar. So if you have any questions or doubts, queries, maybe regarding to what we have covered or even what we have not covered, I'm free to answer these questions. We still have another 10 minutes to go. I'm waiting on your questions. Well, I have a question here from Mr. Shubhrakanta, if I'm not pronouncing it wrong. The question is, may I know what is a load balancer and how DevOps works on it? Well, that's a good question. See, the load balancers will be coming in on the production side. So if you are deploying on a cluster is definitely not one single machine. There are hundreds of machines, okay? And if there are hundreds of machines, you need a load balancer there that would drive the traffic or distribute the traffic to all these hundreds of machines at once. All these 100 machines would be identical, right? And load balancer takes care of distributing the traffic. That's what it is. So it is placed at the primary entry point of your cluster, or maybe the traffic that is coming to your public IP gets routed via load balancer to these systems which are present in the cluster. And load balancers can distribute the traffic based on CPU load or network traffic load or even memory consumption, or it can use some scheduling mechanism for doing it. Okay, I hope that solves the query. Okay, we can get this recording. It would be mailed to you. Mr. Joseph is asking a question. If not developer, how to code in C++ or .NET? Well, if you don't know how to code it in C++ or .NET or whatever project you are using, um, it's a good idea to learn something, right? You should start right away to getting into details about your project, whatever project you're working on. If you are working with code, you should know what goes inside the code, because at some point in time you'd be responsible for handling the configurations. If not, but if you're working in the complete different area of DevOps, like you're very specific to the build engineering and you don't need to worry about other things, well, then that organization is doing the things wrong, but it's good for you. You don't need to run all those different things. But from my perspective, it's good to have that knowledge. We have a question from Prashant. Please suggest puppet training. Well, if you're talking of this course specifically at Edureka, these people cover Puppet, but it's not in the advanced level. But still, you'd get to know a lot of interesting things about Puppet as well. I have another query here from Mr. Ganesh. I'm a college student doing my computer education. How do I learn more about DevOps? But yeah, it's a good question. See, people from different varied backgrounds join DevOps, and it's good because we need people who are coming from different skill sets. So it's a good area, and everyone can join in. You don't need extensive background to be in here, but If you really ask me what people would be asking you in the interviews, get hold of a few tools, because they would never be asking you about culture and structure kind of things. Mostly these things are implemented by the organization management itself, but to be frank, they don't even care about it. If you care about a job, go and learn a few tools. Taking up a courses would greatly help in that. Another question from Mr. Chetan: tools would you what tools will you purpose for blue-green kind of deployment and production? I would rather use Capistrano for that. It's the easiest one to set up the things. Or if you want to do it manually, you can also do it manually by writing some scripts. Well, I have another question here from Mr. Kashif Rehman. What is the best tool to choose from your current experience for DevOps? Puppet, Chef, SaltStack, or Ansible? Well, it depends. If you're willing to pay for it, go for SaltStack or Ansible. Uh, Puppet and Chef work on a different kind of architecture. In these, both the tools, well, I'm talking of the two different kinds of architectures that the configuration management softwares are based on. One is the server client kind of architecture, where the client is responsible for setting up everything on the client end or on the node part. If your client is dead, your node is dead. If there is no network, the client cannot talk back to the server. Hence, in that case, even if the system is up, you will not be able to configure it. So there are some cases where we were in a problem where half of the cluster was configured right and the code was deployed, and half of the cluster was still with the older code. That kind of problems do happen. Whereas on the Ansible or SaltStack kind of tools, the part is completely different. They work on the architecture like doing parallel SSH from centralized system to all the other machines, so that you get a correct report real time whether the things are going right or not. Depends what kind of architecture you use. For me, I would be using Puppet or Chef. Uh, that's what I use. Well, Rajesh Reddy has got one concern that he is exploring Kubernetes, um, and he needs my opinion on it. Well, it's a great software if you are using one. Definitely depends on what kind of application you're running, because when you're using Kubernetes, there is a huge fleet of system that Kubernetes would be abstracting for you. You will not be working at the machine level now. You would be considering all of these things as one single resource, and Kubernetes would be managing all these things for you based on the containerized approach. Well, that's good when you don't need to worry about the different applications that you're running. But if there is only one single application that you want to place, it doesn't make sense to have that abstraction level layer even. You could simply use some configuration software to do your work, or maybe use these days something is coming up new which is called Docker Swarm. Have a look at it. Depending on the application, it really differs. I cannot give my right opinion right now unless and until I know what your software is about. Okay, there are a lot of questions. I'll be coming to each and every question of it. Just hold on for your turn. That's a question from Mr. Deepak. DevOps should have all the below skills, or we need to form a team in each skill? Well, we don't need to form a team in each skill. We need a team that understands everything. Okay, I hope it answers the question. It's pretty much clear. One team that understands everything. Siddharth Singh is having concern about Chef. Also, is Ruby and Python only way to get started with Chef? Well, no. Um, there are very few things from Ruby that you need to understand in order to get started with Chef. It's the really easiest software. It's easier than Puppet and does great stuff than Puppet. So if you're really having a problem deciding over two things, go for it. You don't need to learn even Python or Ruby for that purpose. They have a really small page that picks up very few things from Ruby that you need to understand. And it's as simple as that. You can pick up the things in a matter of minutes. Is QA also part of DevOps model? Yes, it is, but only the automated part. Manual QA we don't consider. We consider only the automation part of it. Question from Prashant: what's the Puppet manifest? Well, it's just like Chef recipe. It's a small script that is written in Puppet's own proprietary language that tells Puppet what has to be configured on a particular machine. That's the only thing. Rajesh has concern here. The question is, my question referring slide about Amazon deployment speed. When will the automation scripts run on the code when you're running deployments so fast? Okay, so these people are having infrastructure that is huge. Okay, not one single cluster. There would be hundreds of different clusters consisting of thousands of different machines running more than 50-60 applications at production scale. So I'm talking of all the machines together, all the applications together. So if you talk of one single application, it might be one deployment per hour. Okay, so or maybe two deployments per hour. It depends. Um, that was a general term taking into consideration all the applications and all the infrastructures from Amazon. Question from Sadashiv: can we use DevOps tools for Windows Azure environment? Do you guide how to work on Windows environment? Specifically with this course, we do not cover Windows, so I'm sorry on that part. But DevOps tools can be used for Windows. Puppet, Chef works with Windows. We have Capistrano that works with Windows. Jenkins works with Windows. Everything that we will be covering works with Windows, but we will not be covering Windows administration part of it. Okay, that's the only thing that we will not be covering. The question from Mr. Vishwesh: and for DevOps engineer, is it necessary to know about programming languages like Ruby, Perl, Python, etc.? Yes, it is. It's really a good to have knowledge. See, you have tools, but not all the tools would be fitting into one another. If you need to gather information or some data from the tools API and creating your own custom application or dashboard for displaying the data, you need to know some coding language. Some serious coding has to be there. Okay. But I don't expect it to be at the very early stages. Definitely, there is going to be a person who would be coordinating with all these tools together. But for a startup, not high-end level of program is required. But still, people would generally focus on the tools rather. Question from Mr. Abhishek. Do we have any open source tool which we can use for alerting from Graphite events? Nagios does provide this kind of capabilities. It interacts and provides an API for um, PagerDuty, I guess, from which you can get nice alerts and also notifications. There's a question from Jayashree. When we say teams should be trained on all tools, does it mean developers also need to be trained on DevOps and build and continuous integration tools? I've seen developers are not very interested in learning admin functionalities of these tools. Well, you are right. I don't say that developers should be trained on all these things. Training has to be there only for the DevOps guys on the admin part of it. Developers will have to be trained only on the section that is hampering them. That means if you set up a pre-commit hook, they should be aware that it is set. It gives there in a particular form and what has to be done in order to resolve it. They don't need to understand how the subversion works. They don't need to understand how the pre-commit hook works. Okay, so only on the functional part they should be aware that this does this and I need to do this after some error is there. Okay, if there is no error, it's a free flow system. They won't even recognize that something's there behind the scenes. So training has to be there for tools for the complete DevOps team, not for the developers. The question from Mr. Nitin: which are the latest tools for monitoring? Is Splunk one of them, or there are more advanced tools? These days, people generally go for Xenos. Go have a look if you are really interested in one. Splunk was being used a few years ago. Now, these days also people use it, but I'm not sure whether it is that much advanced one these days or not. But there is an active community which is growing on across Xenos. I have a question here from Mr. Prashant. What is a deployment tool? Well, deployment tool is a tool that would be taking your artifacts or code and pushing it to the production systems. We'll see on production systems there would be servers, and behind the servers there would be code that has to be executed and the results have to be served to the clients. Now this code continuously keeps changing as per the development that is happening on the developer's machine, right? And code has to be updated. Now this tool would deploy the code there, update it, and make sure that the code actually executes on the production side. Okay, that's what the deployment tool is about. Mr. Kailash has a question. May I know what all are the various certifications on DevOps offered currently? Well, there are no official certifications from big giants or even from smaller companies as far as I am aware of, because that's a very general area and everyone does the things their own way. There definitely are certifications for the tools if you would like to do them. Uh, if you're willing to add certificate from Edureka, these people also provide you with a certificate after doing the course. But from a very maybe if you're talking of certification from the Amazon or something like that, we don't have those kind of certifications offering. Sadashiv has a question. I joined 30 minutes late. Will be a recording available? Yes, you would be getting a recording. It would be mailed to you. Vishweshwar has a question. Is it necessary to know about programming languages like Python, Ruby, etc. for a DevOps person? Yes, it's a must, but definitely depends on what area you're working on again. Prashant, the question, what is a deployment tool? I've already answered that, Prashant. Um, Another question from Mr. Kailash. May I know what all are the okay, it's been repeated. Let me go ahead a bit. What is the best tool for continuous integration? Asked by Vishwesh. Well, Vishwesh, open source and the tool with biggest community across it, providing with thousands, more than thousands of plugins is Jenkins. So if you're willing to use it, I would rather prefer you go for Jenkins in the beginning. But if your company is depending on a few more features that would help it deploy along with continuous integration, it could go with something like TeamCity. Depends, okay? But Jenkins is definitely a starting point if you want to start. Ashutosh has a question like testing is one of the major requirement. What approach should one use in DevOps scenario? Any suggestions for tools? Well, testing, automation testing is what we do, and we cover it up using some CI tools. So that is what it is. Um, every testing tool is different, and as far as the projects and different languages are concerned, every language will be having its own testing tool. All the tools can be triggered manually, and Jenkins can be used to trigger the commands to trigger these tools actually. So eventually the tools are triggered via Jenkins. So no specific tools. Um, Whereas there are plugins that integrate the tools with different CI systems, like we have tools for plugins for integrating JUnit test cases or Selenium test cases into Jenkins out of the box, so that you don't have to code anything. So look for the plugins that the tools are providing, but I'm not aware of any of the tools that provides this kind of integrations out of the box. Definitely plugins are there. Deepak has a question. How about the scope of DevOps in future? Well, as far as this year is concerned, it's been exponential. In future, the tools would be different. It's going more on the cloud and virtual infrastructure side. We will not be depending on any physical infrastructure in the near future. Uh, from the perspective of DevOps architects, these people are doing talks and discussing about possibilities of using the containers and more specifically the Docker for different DevOps systems. Even the tools would be built inside the Docker so that you can pick them up and use them on any of the systems or machines. This is where the DevOps is going. So if you want to be alive with DevOps in next 5 years, I prefer that you should go with virtualization even in the DevOps area. Okay, so scope is huge. Docker is also in the DevOps part. That is where the question is from Aditya. Aditya, Docker was there with the course that Edureka was taking up previously, but now they have scrubbed it off. From specifically not the course part and in the DevOps area, Docker is also a part of DevOps, and it's a big thing these days. Okay, so if you're willing to take up virtualization in DevOps area, go with Docker. Do you provide training on Kubernetes? Is a question from Mr. Rajesh. No, Rajesh, I'm sorry, we do not train on Kubernetes. But if you have any queries or doubts, feel free to ask. If you find me around, okay, I'm free for that. May I know what are the load balancer tool that we have in market? The question is from Shubhrakanta. there are two different kinds of load balancers that are available in the market: hardware based and software based. The leading hardware based load balancer is the F5. Go and have a look at their website. The website is called F5 .net, I suppose, or .com, something like that. And the another one is HA proxy, which is a software based system, which is really a great tool. Sometimes it also surpasses the expectations of a hardware based system. It's really that good. Depends on the traffic though. Okay, so these are two things that you should be having a look at. Another question from Deepak: DevOps is responsible from development to testing to deployment. In that case, it will be overload to the DevOps guy, isn't it? Yeah, great question. That's why it's a team. It's not one single person. Okay, and smart DevOps person would be one who would be automating everything and making it also transparent at the same time. What I mean by transparency is, let's say there's a big pipeline and you need to know where your code is, because you have coded it right now, you have committed it, and you don't understand where you should be testing on which particular machine. Now there could be three different areas for testing. So prepare a dashboard so that people do not treat you as a human keyboard. They don't try and bombard you with all the different questions. Put up a nice single application, because from the developer's perspective, they don't need to be aware of all the admin parts of different tools. Like I said already, you could be using 10 tools and developers will not be understanding even one of them. So create one single dashboard that would interact with all the different tools or all the different stages in your complete pipeline. It would show some nice representation data that this is the code that was committed and it's at this stage at this given point, so that people don't bombard you with questions every now and then. Okay, so automation, along with automation, you should also understand that it should be easily understandable by the people, and they should not be coming to you for every small glitch. Okay, you automate it, but at the same time also protect yourself from that. There's a question from Mr. Joseph. I'm working as an infrastructure engineer past 2 years, but it's necessary to know high-level scripting. Okay, is it necessary to know high-level scripting? We can cover Nagios and Jenkins and Git and Git. Is it necessary? Okay, from the scripting part, well, again, it's good to have knowledge, and that's what we are going to cover. From the necessity point of view, I'm not pretty much sure in what area of DevOps you'll be working, but as a general engineer, from my experience, it is required at some point in time. Okay, you cannot completely scrub it off the book. There's a question from Shubhrakant again: what are the different kinds of tools used for deployments? Okay, if you're talking of the virtualization part of it, Puppet can help you with that. There could be tools like Docker that can come in handy for deployments directly. You deploy on one single box and replicate it. That's the easiest way to do the things. From the tooling perspective, Jenkins can also handle deployment. TeamCity is a continuous integration server that comes in with internal deployment strategies into that. You have Capistrano handling deployments, or you can simply use old school rsync to do the things for you. Okay. Another question is from Vishwesh: what's the use of Docker? It's used for virtualization. You know virtual machines, right? Virtual machines are the systems which run virtually as a complete operating system. Now imagine that you need to install and run Apache server on production. Now for running that one single Apache server, does it make sense to have complete operating system running beneath it? So there would be an operating system, then on top of it, there would be some process management system, scheduling mechanisms, and hundreds of different processes of the operating system itself. And along with that, you install one single web server called Apache. On top of it, you would be serving the things. So your operating system stack would take up a lot of RAM and processing power of the system altogether. Okay, and we can prevent all of this using Docker. So what Docker does, it just creates isolated environments for processes to execute. So there would be one single operating system at the base. That means just like Windows operating system, you install VMware on top of it, and inside VMware you have different virtual machines. Now this scenario will not be there. There would be one single software called Docker, which is running on Windows. Actually, Docker does not run on Windows. Let's consider Linux. So there would be underlying Linux system providing the kernel support for the Docker, and inside Docker you would be running different applications. All of these applications would be isolated from one another, and each of the application does not require underlying operating system for it. So the load and the uh, that the system would be taking, and the amount of RAM and the resources that are being spent in creating this kind of isolated environments is pretty much slow. Sorry, it's not slow, it's low, and you get very fast performance out of it. That's the use of Docker. Okay, eventually you create isolated environments for the processes to run. We have a question from Rajesh. What kind of automation we do in DevOps? Because we have testing automation tools like Selenium and Jenkins itself, and automated build CI tools which take care of building and deployment. If you already have automation tools in place, the kind of automation that we do is from the development machine itself. Okay, so I'm not only talking of automated testing. I'm talking of everything that comes before and after automated testing. Okay, so that's what DevOps will be covering. If you already have automation tools and this kind of stuff, they would be automatically triggered using the CI systems, so that the code passes through them, you check everything is working fine, and after that the code will be built and then deployed somewhere else, maybe even on production systems. And that would happen automatically, not only testing. Another question coming in from Shubhrakanta: code branching and merging is a part of DevOps work? Yes, to some extent, of course, because if you're talking of branches, you're talking of different codes. If you're talking of different codes, there would be different jobs that would be taking the code from these branches, then deploying, building and deploying them on different machines, and then testing them. And out of these things, then you'd be figuring out which has to be deployed eventually to the production, maybe. So yes, that's a part of it. Merging is also part of DevOps. If you're targeting the architecture, the build pipeline is also differently architected in different organizations. So if you have some systems that goes like trunk, then pre-production, and then production, there would be three different branches through which the code would flow, and different teams would be working on different branches as the code moves from one part of your system to the production areas. So automated merging is required there, which has to be taken care by some automated system. Maybe you write some scripts for that, or use Capistrano for that, or Jenkins can also do it. Depends, right? Yes, but that's a part of DevOps. Another question from Jayashree: is it a best practice to keep on changing tools in DevOps suites? I guess we will be having one or the other tool coming in market for DevOps competency. Great question. Um, it's not a good idea to keep on changing tools. The first thing. Second thing, it's also not good to depend on tools for everything. Okay, so if you really think that the tool is in market for a bit longer, or is a promising one to stay in the market for next at least 3 to 4 years, it would be a good idea to choose that tool. But if you don't rely on the tool, if you don't have confidence in the community that is around the tool, do not choose it. Okay, go on for some manual kind of stuff that you can code yourself or keep customized. All right, so that's what my suggestion would be. But definitely it's not good a good idea to keep changing the things unless and until it is actually required, right? DevOps does the integration part. Yes. This question from Rajesh: yes, Rajesh, DevOps does handle integration part as well. So everything that is beyond the developer's perspective, that means after the code leaves the developer machine, has to be handled by DevOps. Integration is also the part of it. What is the difference between Git and CVS? Well, as far as I understand, CVS and Subversion are on one side, and Git and Mercurial would be on another side. Now, architecture is the basic difference. The architecture of Git is distributed. That means you don't have one single server. Everything is distributed on all the client machines. There would be no one single server in Git. Whereas in CVS, you have a centralized system or a server where all your code would be there along with the history. Okay, on your client side or on the developer machines, there will be no history saved, but there will be only the code repositories or the workspaces that are replicated. But in Git, the step is completely different. You have repositories on both the sides. You first commit to your repository, and then when you want to replicate it, you simply push the code from one machine to another one. So it could be any machine. At that point, you could push the code to your friend, or push it to some integration team, or push it to the centralized repository also. Okay, so that's it. There's an excellent question from Aditya. Continuous deployment, continuous development, what are the differences? Well, continuous development, when we talk of it comes from the agile perspective that is implemented on the development side. It's also called XP in some cases, okay, or extreme programming. That's continuous development. When we talk of continuous deployment, we are talking of the complete continuous or automatically running build pipeline till the deployment stage. So once the code leaves after continuous deployment from the developer side, the continuous deployment would be triggered eventually after passing through continuous integration and continuous delivery phases. Continuous integration would be covering automated testing, filtering, notifications, building integration, and after that, on the delivery side, there would be smoke testing, then integration testing, then user acceptance testing, regression testing happening, and on the deployment side, you would be actually deploying that code to the production. The question from Shubhrakant again: what is the difference between doing continuous integration in TFS and other tools available in market? Um, well, I'm not sure what the exact difference is, but from conceptual point of view, all of them does the same thing. They automate a part of the stuff that you are doing manually. Okay, that's what the continuous integration system or server concentrates at. It might have some other features, but I'm not sure what are the other features that are available specifically with the tool that you're using. May I know something about Hyper-V? Question from Mr. Vinod. Well, Vinod, Hyper-V is exactly same as Zen, if you're aware of. So what it actually does is it provides you an underlying layer that sits on top of your hardware, okay? And on top of that machine, you can have different virtual machines installed. So take an example. You have a host operating system inside which you install maybe the systems like VMware or virtual machine, sorry, not virtual machine, virtual manager, or something like virtual PC or any other software. Once you have that, inside that software you can execute multiple operating systems, right? But you still need the base operating system. So what Hyper-V kind of system does, it is actually called a hypervisor that sits directly on top of uh, your hardware. There will not be any operating system between the hardware and Hyper-V. So Hyper-V is the minimum kind of operating system that is there. And on top of Hyper-V, you can directly install virtual machines or create virtual machines. You don't have to have any intermediate layers in between. Okay, that's what Hyper-V is about. Another question from Vishwesh: do DevOps engineer must have every good knowledge on all the tools or have decent knowledge to manage things or issues? Both of them, I must say. Since, let's say, if you are a person coming in from the coding background, you can handle issues that are related to code. If you are a good DevOps engineer who is having very extensive knowledge about the pipelines and the tools that you have configured and integrated, you should be able to answer all different sort of questions. So generally in DevOps, we don't have positions for support engineers. There's nothing like that, because if you are working, you should be knowing all of the different aspects and perspectives of the system together. Okay, it's not that you just configure and leave the systems for other to use. There's another question coming in from Mr. Rajesh. We should have admin level knowledge for CM tools like Git and code repo like SVN. Is the statement right? Yes, it's right to some extent. Well, we would be covering installation of the code management tools, both Git and SVN. But it doesn't mean that you shouldn't be knowing anything that happens on the client side. You should know how to commit the code. You should know how to check out the code, because sometimes the people may run into issues and they will ask you for help that how this is done on the client side. You should be aware of that part as well. Another question that is coming in from um, Ajay, Mr. Ajay Sharma: DevOps also fits in big data deployment, development. Yes, it does. So whenever there is a development or you code something, um, it has to be tested, right? So when we're talking of big data kind of things, or you're talking of something like Hadoop that runs in the background, you can have a pipeline set up to automatically have instances these big to be set up and installed and tested automatically. Uh, I would take an example that I've done at Intel. So at this level, these people have got some security software that has to be tested on more than 120 different operating systems, ranging from systems like switches, mobile phones, to practical computers and car systems. So yeah, that's big. Okay, DevOps has to be there. Another query is Docker is right DevOps tool. It's a DevOps tool. How you make it right, it's all up to you. It depends, right? According to the scenarios. So, well, any more queries? I hope I have understood and answered majority of your questions. I've gone through each and every of them. If I actually missed something, please feel free to shoot the questions. I'm still here for another 5-10 minutes, and if you have got time, I can also extend it. There's a question coming in from Shubhrakanta. Why we make offload balancer of particular server while deploying any build to specific server? Well, not actually. We do not turn off the load balancer actually. We shouldn't. But if you're doing so, you are actually causing downtime for your application. If that's the scenario you're working on, it might be the requirement for your uh, system or application. I'm not sure. But what we generally do is we never turn off the load balancers. We keep them on. We control everything on the config side or in the configuration on the node side. That's what we do, so that there is no downtime actually for the servers. Even in the deployments which are done with the rolling strategies, you would never you would never turn off the load balancers. You'll keep them always up, and the traffic would be served there. I hope I answered your question right. There's another question coming in from Vishwesh. What is the difference between hypervisor and containers? Well, these are two very different things. You cannot compare them. Hypervisor is the stuff that helps or creates underlying layer for virtual machines to run on top of them. Containers on the other side are just isolations, or is a technology that isolates different processes from one another. So that process should not be able to see one another. They should not share anything between one another. So that process can be anything. It could be even a VM, complete VM can be installed inside a container. Could be done, but people generally use it for at the process level. Okay, so you cannot compare both of them. There are completely different two things. You could actually compare virtual machines and containers. So virtual machines are also isolations, but they run a complete operating system inside of them, whereas containers work on the idea called layers. So on top of your kernel, they would be creating their own separate layers, and they would be interacting to kernel using their isolated environments. So, and containers create isolated environments using the same kernel module from the underlying operating system, whereas in virtual machines, they have their own operating systems very different. Um, well, there's a question here from Mr. Raul. Purpose of bind module in Puppet. I'm not pretty much sure what it does at this point, so I will not be able to answer the question for you. Any more queries that are coming up? There's well, Rahul, if you are mentioning about bind 9 or something like that, which refers to setting up DNS, it could be related to that, but I'm not aware of anything that talks specifically in connection to Puppet. There could be a different module that would be able to install a DNS or something, that kind of service with bind, right? So that could be the case that you're asking, but I'm not sure. I hope that answers your question. There's another query coming in from Shubhrakanta. I don't know whether replication issues are being solved by DevOps. If so, when any replication issues coming in from HP side scope, is DevOps responsible for monitoring the tool? Yes, monitoring is a part of DevOps team. So anything that you do to the production, you should be aware of any issues that are coming in. So even before they are caught by the clients, you should be aware that the issues are happening on your production systems. So telemetry, setting up the telemetry and notifications and monitoring and logging, all is a part of DevOps team, everything. But there is another scenario. These days, people don't like DevOps people to change anything on the production side, which is already running. They are more stringent about the changes that are happening on the production. So they would not like to replace their ops team completely. If this is the background of your organization, you will not be um, responsible or have to worry about these issues in production. Okay, but ideally you should. Another question is any monitoring tool DevOps using for rebuild the monitor or how you resolving web farm framework issues? Well, let me structure the question. Is there any monitoring tool that we are using in DevOps for uh, monitoring, or how do we resolve the web farm framework issues that happen in the production side? Um, for monitoring, we generally use Nagios. That's the de facto standard that we generally use. Okay. From the web farm issues, that means which are related to infrastructure directly, we use something like Foreman that can help us in resolving the stuff, or also figuring out the problems with the infrastructure that are already there. Another question from Mr. Rahul: is Puppet only for static configuration across virtual machines? Um, I'm not getting. Is Puppet only for static configuration across virtual machines, multiple virtual machines, you mean to say? Um, Not just static. We can also do dynamic kind of configuration that changes based on the systems. So let's say if you have a machine that is a web server, or there is a machine called a database, or different clusters that are hosting different kinds of web servers or different applications, Puppet can handle that just well. Okay, or it can also change the configurations on the fly. Let's say during the deployments you need to have different configurations there, you could do that. Or even before deployments, if you want to change something or remove a user from the complete cluster, you could do that at a minute's notice. Okay, so it's not just static, it can handle dynamic configurations all across the different systems. uh, Definitely, if you're talking of virtual machines, you're talking of the infrastructures, that's what I understand. Puppet should be able to do that. But if you say that virtual machines have to be configured from the scratch, if you don't um, even have a virtual machine, you need to build a virtual machine, Puppet cannot help you build one. Okay, for that, Vagrant would be the right tool in that cases. All right, guys, we are running out of time. We have actually shut up the time by another 33 minutes. If there are any more questions coming up, I would be here for another 2-3 minutes. We'll take the questions, and then we'll be ending the session. All right. So, okay, another question: how continuous integration happens in TFS for each check in a new build is triggered? Is it the work of DevOps for check-in and check-out? Okay, yes, that's managed by DevOps. And for every check-in, there would be a build triggered, but you can control that. You can actually have every build triggered in a sane manner. Not all the check-ins would be triggering a build. Checking and checkout is not the work of DevOps. That is the client-side operation that is happening. But you have to eventually check in and check out the code automatically using your continuous integration system. Okay, just in order to take the code down so that you can build uh, something out of it. Okay, that's the work of DevOps. You can, but the client-side operations, you will have to help them out, but that's not considered to be a DevOps work. What's the difference between Vagrant and Docker? Vagrant is a tool that helps you build the virtual machines. Let's say I want to have a virtual machine that runs on my system, has got Ubuntu installed in it, and have got a few of softwares already built and configured in a way that I want to be. I would like to have. Um, so that part of completely building a virtual machine and setting something inside of it is handled by Vagrant. Whereas in Docker, Docker is a process management system that isolates different processes from one another. It's completely different. You cannot have complete environments inside of it. Actually, you could, but that is not the use of Docker. Docker should not be used for that purpose. So that's it. Vagrant configures your virtual machine, whereas Docker provides you with isolated environments for your processes. Okay, so these are two different things. Questions coming in from Mr. Nitin. Are there any good resources available online for viewing a live example of a DevOps tool in play? Yes, there are many and plenty. Uh, YouTube is the best place to look for these things. If you know a tool's name that you want to look for or check for demo, it would be there. If you're talking of a complete build pipeline, yes, there are examples for complete build pipeline as well. So you'll have to search for it though. Okay, I'm not aware of any such links, but I've seen the videos, but I don't remember any such links right now. But YouTube is the site for that. Another question from Shubhrakanta: is it the work of DevOps for making MS build packaging? How do you do it? Yes, it's a work. If it has to be automated on the CI side, it has to be handled by the DevOps team. But very first, you need to understand the process that is happening on the developer end, how these people are managing it, building it, and testing it on their system. And what you need to do is just need to understand and automate that part in your CI system. That's it. But yes, it's covered in DevOps. So, all right, guys, I'll stop now. So, I hope I answered your questions correctly, and all of your questions and queries have been answered. If you need some support or still have some doubts or queries to be answered, you can mail us at Edureka. Okay, connect with these people. They are friendly people and they can help you with all your questions and support tickets. Even if you maybe don't register or don't join the courses, that's a different part. Okay, you would all be getting uh, the recordings of this session so that you can go through it again if you have any queries or doubts for last maybe 45 minutes what we have spent answering the questions. You can go through it at your ease. All right, so have a great day ahead. I'll take your leave for now, and happy DevOps. Thank you so much for attending this session today.